This video will introduce you to special right triangles, and in particular, we're going to talk about the first of two special right triangles that we're going to look at this year called the isosceles right triangle. So let's take a minute and discuss what it means for a triangle to be both isosceles and right. And this is probably actually even review. So isosceles, remember, means that it has two sides that are exactly the same length. Right means our triangle contains a right angle. So I'm going to start with a right triangle. Remember that in a right triangle, or in any triangle for that matter, the longest side always has to be opposite the largest angle. So the hypotenuse in a right triangle must be the longest side, and if it's the longest, that means the two congruent sides would be the two legs. Recall also that if a triangle has two legs that are congruent, its two base angles must be congruent as well. And if each of those angles are congruent to each other, they must measure 45 degrees. Because the isosceles right triangle, like any triangle, must have angles whose sum is 180 degrees. All right, so let's take a look at how we can use this isosceles right triangle to find some side lengths. I'm going to introduce you to the idea that in an isosceles right triangle, the length of the hypotenuse must always be square root of 2 times the length of either leg. As honor students, you should understand where this comes from. So I'm going to use the Pythagorean theorem to explain. And again, I'm going to pretend for the time being that we don't know that the length of the hypotenuse is equal to the leg times the square root of 2. So how do we know this, or where does this come from? I'm going to start with any generic, general isosceles right triangle. For lack of something better, I'm going to call the length of their legs x. The Pythagorean theorem tells us that x squared plus x squared has to be equal to c squared, or in other words, the hypotenuse squared has to be equal to 2x squared. And when I take the square root of both sides now, I know that the length of the hypotenuse has to be equal to the square root of 2x squared. Simplifying that radical tells me that the hypotenuse is going to be x times the square root of 2. So that's where that comes from. It's just Pythagorean theorem. What's really important here and what you need to know is that in any isosceles right triangle, the length of the hypotenuse will always be the square root of 2 times the length of either of the legs. Sometimes we might say that the three sides then are in the ratio 1 to 1 to square root of 2. Let's take a look at how we can use this to solve problems. This is kind of cool because it allows us really to do two things. It allows us to find the length of some sides in exact values, meaning not a decimal approximation from the calculator. It's also like a shortcut. It will allow us to find these exact values very quickly and very easily. So first things first, when they tell us exact values only, what they really mean here is they mean simplest radical form. What I like the most about this is that you won't need a calculator in order to find these. So let me go ahead and get these notes real nice here. Radical form. And we're going to use this idea that in the isosceles right triangle, we can find the length of the hypotenuse by multiplying the length of either of the legs times the square root of 2. All right, so when I jump into letter A, it looks like I'm trying to find the value of x and trying to find the value of y. They've given me this isosceles right triangle. I know that the missing angle there is 45. And if the two base angles are congruent, I also know that the two sides opposite those base angles are congruent. I'm also told here that the length of that hypotenuse is 10. Recall that I found the length of that hypotenuse, or someone found the length of that hypotenuse, by multiplying the length of either one of the two legs times the square root of 2. Multiplying either of those legs times the square root of 2 will give us the length of that hypotenuse. So to go backwards and find the length of the missing leg, well, backwards or undoing multiplying by the square root of 2 must be dividing by the square root of 2. So x must be equal to the length of the hypotenuse 10 divided by the square root of 2. And likewise, y must be the length of that hypotenuse 10 divided by the square root of 2. All right, in letter B, same kind of idea. Again, we have this 45, 45, 90 right triangle, or in other words, the isosceles right triangle. So like letter A, our x value and our y value here represent the legs of that right triangle. And since to find the hypotenuse, we multiply the leg times the square root of 2, then to work backwards, in order to find the leg, we must take the hypotenuse, which is 14, and divide that by the square root of 2. So the lengths of both of our legs here in letter B must be 14 divided by the square root of 2. It might be super tempting to plug that into the calculator in order to find the quote-unquote real answer. But keep in mind here, we want our values to represent exact numbers, and therefore it's okay to leave our answers in simplest radical form. Letter C, again, what we know here is the length of the hypotenuse. And remember that we multiplied the length of either leg times the square root of 2 in order to get that hypotenuse. So to work backwards now and find the length of either leg, we're going to take the hypotenuse, 8 square roots of 8, and divide that by square root of 2. Recall from your algebra years that when we are simplifying here, we're going to do 8 divided by 1. And then to do the square root of 8 divided by the square root of 2, I'm simply going to divide the 8 by the 2. And because both of those started out underneath the radical, their quotient will end up under the radical also. So this ends up being 8 times 2, which gives me, for the length of either one of those legs, 16. So there was a nice little algebra review there and working with radicals. Letter D, again, I have this 45, 45, 90 right triangle, or this isosceles right triangle. To go from the leg to the hypotenuse, we multiplied by the square root of 2. So in order to start with a hypotenuse and find the length of either leg, we have to divide by the square root of 2. And that makes both of those legs 11 divided by the square root of 2. All right, there are two important things that I need to talk about in order to finish up on this with this video. The first thing is that once kids learn this, it's such a nice, short, fast, easy shortcut that they want to use it all the time. My words of wisdom here, my word of caution is be careful, because this only works when you're working in an isosceles right triangle. So make sure that you're using this isosceles right triangle before trying to use the shortcut. So the 1 to square root of 2 ratio only works when you're dealing with an isosceles right triangle. It does not work for other types of isosceles triangles. It does not work for other types of right triangles. Only when the triangle that you're working for or working in is both isosceles and right. The other thing that I need to let you know is that when you go to do the check your understanding questions in Delta Math will not let you input an answer that has a square root in the denominator. Square roots are, however, okay in the numerator. So if I take a look at the answers that I got for the questions that I did in the video, letter A contains an answer where I've got the square root in the denominator. Delta Math, again, is not going to like that square root of 2 in the denominator. So just a quick recap if you don't remember how to rationalize a denominator from Algebra 1, we're going to rationalize or do what's called rationalizing that denominator by multiplying both the numerator and the denominator of that fraction by square root of 2. We can do this because any number divided by itself is 1. So square root of 2 divided by square root of 2 is 1. And multiplying any value times 1, we know, doesn't change the value of that number. So when I end up rationalizing the denominator for letter A, I end up with 10 square roots of 2 over 2, which ends up being 5 square roots of 2. Applying a similar process to letter B, again, I'm going to go ahead and multiply by root 2 over 2, which gives me 14 times the square root of 2 in the numerator. Square root of 2 times the square root of 2 is 2, which tells me that the answer there would be 7 square roots of 2. Letter C doesn't have any square roots in the denominator, so I'm good to go there. But for letter D, when I rationalize the denominator there, I end up with 11 square roots of 2 over 2, which can't be simplified further, leaving my answer in radical form 11 root 2 over 2. And again, it's okay to have a square root upstairs in the numerator, but not downstairs in the denominator. So that'll be helpful for you when you do your check your understanding questions in Delta Math. All right, as always, if you have questions, if there are things that don't make sense, make sure you write them down so you can ask them the next time that I see you when you come back to class. And as always, thank you for the gift of your time in watching the video.